all, welcome back. This is 4.2 video, but we're going to start with a bell ringer for 4.1. So go ahead and hit pause, solve this problem, and I'll meet you down below at 4.2. Okay, 4.2 is percent composition, page 24. We're moving right along here. Percent composition is pretty simple to do. It's just like calculating a percentage. So it shouldn't be too tough, but we're going to say the amount an element makes up of a compound. All right, so we're going to be seeing like how much an element makes up of each compound. And so we could find all of it, right? Or we could just go ahead and go with one element. It'll kind of depend. We'll see examples as we find there. So our steps are going to be exactly kind of similar to what we did yesterday. The first thing we have to do is we have to find molar mass. So that's what we do. Then we divide that element's total mass by the molar mass and multiply by 100. Label it with a percent. And again, kind of like we did yesterday, we're going to keep 2 decimals in our answers to keep it simple here. All right. Okay, so here we go. So find the mass percent of each element. All right, this one's each element in H2O. So we have 2 elements. So let's kind of write it out like we did in our notes yesterday. We had H, we had O. Let's blow this up a little bit. We have 2 H's times 1.00794. And we have 1 times 15.9994. This is what we did yesterday. We're still working on what we did yesterday. 2.01588. And this one is 15.9994. And then we added this up, right? And with our sig figs, we came up with 18.02 grams per mole. That was kind of a quick review of what we did yesterday. Here's our step today. The only thing we're going to change today is we're now going to take this mass, the element's total mass, by the 18.02 and then multiply by 100. So divide by 18.02 and then times 100. And that'll tell us what part of the whole we have. So 2.01588 divided by 18.02 and then times 100. We're going to get a fairly small percent, which makes sense. 11.19% is hydrogen, which makes sense because only 2 grams of that 18. All right, then we do the same thing with our oxygen. All right, and then times by 100. And we're going to get 87 point, my decimal got a little high there, 87.79%. And this should be really, really close. Like when we add these up, we should get really pretty close to 100. Like when I add those two up, I get 99.98, which is pretty close. All right. So that is finding each element. So if you had 3 elements, you would do the same thing. Right? Okay. Awesome. Let's try another example. This time it says, find the percent mass of oxygen in iron 2 chlorate. Well, this is the one we did yesterday as well, so you could flip back if you wanted to. But I'm going to just resolve it because it doesn't take us that long. So our formula, iron 2 chlorate, we've got this right here, right? And so our Fe, we've got 1 times 55.845, which gives us 55.845, right? We have Cl. We have 2 of those times 35.4527. Man, my writing is rough there. Okay. And that's going to be 70.9054. And then we have our O. We have 6 times 15.9994. And this one comes out to be 95.9964. Then we added these babies up, right? Still working on finding the molar mass. All right. So 222.75. So this, like we said, is going to be very similar. So our next step, now that we found molar mass, is to divide This number, since we're just looking for oxygen in this case, just oxygen, we're going to take 95.9964 and divide by 222.75 and then times that by 100, and that's going to be our mass percent of oxygen. And that should be 43.10% when we round it to 2. So 43% is oxygen, which makes sense because 95 is almost half of 222. It's not quite there, but kind of close. All right, I hope that makes sense. See you next time.